Question 1. For each Azure AI Foundry for VS Code extension workflow, drag it to the appropriate boxes in the correct match column to align with its universally true description in the option column. Each item may be used once, more than once, or not at all. Initialize an Azure AI Foundry-based workspace from within VS Code. Project creation. Choose a model and push it to a hosted endpoint from VS Code. Model selection and deployment. Try prompts and responses interactively without leaving VS Code. Playground testing. Define and register an autonomous component that can take actions. Agent creation. Now that we've gone through the question and the correct answers, let's break down why each match is correct. First, project creation fits initializing an Azure AI Foundry-based workspace, because that step is where you establish the project context directly inside VS Code, similar to starting a new repo or solution before writing code. Next, model selection and deployment matches choosing a model and pushing it to a hosted endpoint, because you are selecting what will run and then deploying it, so applications can call it, like publishing an API for your app to use. Additionally, playground testing matches trying prompts and responses without leaving VS Code, since the playground is designed for quick prompt iteration in the editor, similar to testing requests in a built-in console before wiring them into code. Finally, agent creation matches defining and registering an autonomous component that can take actions, because an agent is the part that can follow instructions and invoke tools or workflows, like a support bot that can look things up and then act on the results. Consequently, configure Azure policy and virtual network peering stay unused, because those are governance and network tasks outside the extension's core AI app workflow. Fill in the blanks by selecting the correct options from the drop-down menus. Balancing model selection often involves a trade-off between cost and quality, where developers assess price per token against metrics such as coherence, accuracy, and fluency. Now that we've gone through the question and the correct answers, let's explain why these choices fit naturally. First, cost works because it focuses on what you pay to use the model, often measured per token, which becomes a major factor when usage scales in production. Next, quality works because it reflects how strong the model's outputs are, including whether responses are coherent, accurate, and fluent, which is exactly what teams weigh against the price. However, latency is mainly about speed, not the financial versus performance balance. Likewise, deployment is about where and how the model is hosted, not the evaluation trade-off. Finally, openness relates to licensing and customization, which is a different consideration from cost versus output quality. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. To restrict results to a specific kind of connection, call connections.list. Connection type go connection-type.azure OpenAI, where the parameter expects a valid enumeration rather than a free-form string. We've locked in the completed sentence, so now I'll explain why each filled part is the only one that makes the call valid. First, connection type is correct because it is the exact named parameter used to filter the list results by connection type. Next, connection type.azure OpenAI is correct because the SDK expects an enum member, not a loosely typed label, so you must pass the defined value from connection type. Additionally, valid enumeration is correct because it reinforces that the filter only accepts one of the allowed enum options, not free-form text. However, if you use the wrong parameter name or passed plain text instead of the enum, the filter would not behave as intended, similar to querying a database with an invalid column value. Question 4. For each potential data connection below, drag it to the correct category to indicate whether it's supported for adding grounding data to an Azure AI Foundry project. Azure Blob Storage, Azure Blob Storage, supported connections. Azure Data Lake Storage Gen 2, supported connections. Microsoft OneLake, supported connections. Amazon S3, not supported connections. Google Cloud Storage, not supported connections. We've gone through the question and the correct matches. So let's walk through why each one belongs where it does. First, Azure Blob Storage is supported because it's an Azure native storage option that Azure AI Foundry can connect to for grounding, like pointing your app to a known container of documents for retrieval. Next, Azure Data Lake Storage Gen 2 is also supported because it's built for enterprise-scale data in Azure, so it fits naturally when you want grounding across large structured or unstructured data sets. Additionally, Microsoft OneLake is supported because it's part of the Microsoft Fabric ecosystem, so it aligns with Microsoft integrated data sources that can be used across the organization. However, Amazon S3 and Google Cloud Storage are not supported in this context because they are external cloud storage providers, and this grounding connection workflow focuses on Azure native and Microsoft integrated sources. Consequently, the Azure and Microsoft options go under supported connections, while the non-Azure cloud options go under not supported connections. Question 5. For each statement below, indicate whether the answer is true or false. BERT is cited as strong at understanding short texts. GPT-2's pre-training on unfiltered internet content can introduce biases. True. Model cards referenced in the portal are hosted on Hugging Face. True. Every model in the catalog can be fine-tuned in your hub by default. False. We've confirmed the answers. So now let's connect each one to the underlying idea it's testing. First, BERT being strong at short text understanding is true because it's commonly positioned for language understanding tasks, so it performs well when you need to interpret concise inputs like search queries or short support tickets. Additionally, GPT-2 training on unfiltered internet data being able to introduce biases is true, because broad internet text can contain biased patterns that the model may learn and reflect in outputs. Moreover, model cards being hosted on Hugging Face is true, since portals often link out to the official model documentation pages there for details like intended use and limitations. However, the idea that every model can be fine-tuned by default is false, because fine-tuning depends on availability factors like region support and quotas, meaning two teams can see different options even inside the same platform. Question 6. A financial services company needs to scan thousands of invoices, automatically extract fields such as vendor names and totals, translate content into English for standardization, and then store the results in a searchable system that can later be used to ground generative AI queries. Which combination of Azure AI services best supports this requirement? Select one answer. Azure AI Document Intelligence and Azure AI Search. B. Azure AI Custom Vision and Azure AI Translator. C. Azure AI Vision and Azure AI Face. D. Azure AI Translator and Azure AI Foundry Content Safety. The correct answer is A. Azure AI Document Intelligence and Azure AI Search. Let's map the scenario to the services so it's clear why this pairing wins. First, Azure AI Document Intelligence is built for extracting structured fields from documents like invoices, so it can pull vendor names, totals, and other key values automatically across thousands of scans. Next, Azure AI Search handles the searchable storage requirement by creating an index over the extracted results, which is exactly what you later use for retrieval and grounding in a generative AI workflow. Meanwhile, Custom Vision is mainly for training image models and is not the best tool for invoice field extraction, even if Translator could help with language standardization. Similarly, Azure AI Vision with Face does not create a searchable index for grounding, and Face is unrelated to invoice processing. Finally, Translator plus Content Safety focuses on language conversion and moderation, but it still misses the two core needs here: structured extraction and search indexing. Question 7. A team is developing a loan approval model. They plan to add a commercial biased detection toolkit at the end of the workflow before deployment. They believe this is enough to guarantee fairness. Based on responsible AI principles, how should they adjust their approach? Select one answer. A. The toolkit alone is sufficient because fairness problems can always be detected and removed after training. B. Fairness must be considered throughout development, starting with representative training data and subgroup evaluation, not just with tooling at the end. Fairness is irrelevant in financial applications because regulations already ensure equity. D. Bias cannot be mitigated in AI, it must simply be accepted. The correct answer is B. Fairness must be considered throughout development, starting with representative training data and subgroup evaluation, not just with tooling at the end. Here's the key idea behind that choice. Fairness is not a final checklist item. It's a life cycle responsibility. First, you start by checking whether your training data represents the real applicant population, because missing or underrepresented groups can cause uneven approval outcomes. Additionally, you evaluate performance by subgroup, for example, comparing approval rates and error patterns across age ranges, income bands, or protected classes, so you can detect disparities early. Consequently, the toolkit becomes one tool inside an ongoing process, not the process itself. In contrast, option A is unrealistic because not all fairness issues are easy to detect or remove after training. Moreover, option C is wrong because regulations help, but they do not automatically guarantee your model is fair. Finally, option D is wrong because bias can be mitigated through better data practices, testing, and iterative monitoring, much like how banks routinely audit decision processes for compliance and equity. Question 8. To use default Azure credential in a Python app that connects to an AI project, which additional package must be installed? Select one answer. A. Requests, Azure CLI. C. Azure Identity. D. Azure Core. The correct answer is C. Azure Identity. Let's tie that directly to what default Azure credential actually is. First, default Azure credential is implemented in the Azure Identity package. So without installing Azure Identity, your code will not have the credential class available to import and use. Additionally, this package is what handles the chained authentication flow. For example, trying environment credentials, managed identity, or developer sign-in methods, depending on where the app runs. In contrast, Requests is just a general HTTP library and does not provide Azure credential classes. Likewise, Azure CLI is a command line tool that can help you sign in locally, but it is not the Python package that contains default Azure credential. Finally, Azure Core provides shared SDK utilities, but it is not the package that implements the identity credential itself. Question 9. For each statement below, indicate whether the answer is true or false. Prompt quality is unrelated to output quality. False, a prompt must adequately convey user intent and the desired outcome to be effective. True. In text generation tasks, a prompt can be a sentence or paragraph that initiates generation. True. For question answering, a prompt can be a query requesting information on a specific topic. True. Let's walk through the logic behind each statement so the true and false choices feel obvious. First, the idea that prompt quality is unrelated to output quality is false, because clearer prompts reduce ambiguity and guide the model toward the right scope, tone, and level of detail, which directly improves the response. Next, it's true that a prompt must convey intent and the desired outcome, because the model can only follow what you specify, like telling a coworker not just the topic, but what you want delivered, a summary, a plan, or a recommendation. Additionally, it's true that a prompt for text generation can be a sentence or paragraph, since even a short starting can define the topic and constraints that kick off generation. Finally, it's also true that prompts for question answering can be direct queries, because asking a focused question is one of the most common prompt patterns for retrieving a specific explanation or fact. Question 10. Arrange the items to reflect the order of roles within a single chat completion training exchange. Instruction: Drag and drop the items into the correct order, starting with the first roll at the top. System message, user message, assistant response. We've set the sequence, so let's clarify why this order is fixed in a chat completion exchange. First, the system message comes first because it defines the global rules, behavior, and constraints that govern everything that follows, like setting the ground rules before a meeting starts. Next, the user message comes second because it introduces the actual request or task the model must respond to. Finally, the assistant response comes last because it is the model's generated reply to that user request, produced under the system-level constraints. Consequently, this order stays consistent as the core pattern of instruction, request, and response. Question 11. You're building a chat application that uses OpenAI models hosted in Azure AI Foundry. Which two interfaces should you plan to use to work with those endpoints? Select two answers. Azure AI Foundry Models API, B. Azure OpenAI and Azure AI Foundry Models API, C. Azure Resource Graph API, D. Azure Monitor Metrics API. The correct answers are A. Azure AI Foundry Models API, plus, and B. Azure OpenAI and Azure AI Foundry Models API. Let's connect the requirement invoking hosted OpenAI model endpoints to the right interfaces. First, Azure AI Foundry Models API is the core interface used to work with generative model endpoints hosted in Foundry, so it directly matches the need to call those deployed models from your chat app. Additionally, Azure OpenAI and Azure AI Foundry Models API is purpose-built for chat-style interactions with OpenAI models hosted in Foundry, so it aligns with the messaging pattern your application will send and receive. In contrast, Azure Resource Graph API is for querying and inventorying Azure resources at scale, not for running prompts against model endpoints. Likewise, Azure Monitor Metrics API is for telemetry and monitoring, which helps you observe performance, but it is not how you send chat requests to the model. Question 12. You need a model for a chat application and want to fine-tune it in Azure AI Foundry. You also must ensure the model is available in your hub's region and eligible for fine-tuning. What should you do first in the portal? Select one answer. A. Filter the model catalog by fine-tuning task equals chat completion, then verify regional availability and quota before selecting a base model. B. Pick any model from the catalog and rely on deployment to handle regional constraints. C. Download the model card and start a training job without checking quota. Choose BERT because it's better at short texts, regardless of task type. The correct answer is A. Filter the model catalog by fine-tuning equals chat completion. Then verify regional availability and quota before selecting a base model. Here's why that first step matters in the portal workflow. First, filtering by the fine-tuning task ensures you're only looking at models that actually support chat completion fine-tuning, so you don't waste time evaluating models that cannot meet the objective. Next, checking regional availability and quota up front confirms the model can be used in your hub's region and that you have the capacity to run the fine-tuning job, which prevents failures later in the process. In contrast, picking any model and hoping deployment resolves constraints is unreliable because not every model is offered in every region or within your current quota. Likewise, starting a training job without verifying quota can fail immediately, even if the model looks suitable on paper. Finally, choosing BERT, regardless of task type, is incorrect because model choice must align with the chat completion fine-tuning capability, not just general short text strengths. Question 13. Which statement accurately reflects the advanced options and reproducibility behavior in the portal? Select one answer. A. Default and maximum batch size are universal across models, and setting a seed guarantees identical results. B. Learning rate multiplier must always be 0.02, and n epochs must always be 1. C. Seed controls quota and regional availability, while n epochs controls deployment speed. D. Default and maximum batch size are model specific, and setting a seed aims for repeatability but can differ in rare cases. The correct answer is D. Default and maximum batch size are model specific, and setting a seed aims for repeatability but can differ in rare cases. Here's why D is the only statement that matches how these advanced options behave. First, batch size limits depend on the specific base model, because different models have different training constraints, so the portal can't apply one universal default or maximum to everything. Additionally, setting a seed improves reproducibility by reducing randomness in the process, so repeated runs tend to be more consistent. However, seeds are not an absolute guarantee, because underlying compute behavior and non-deterministic operations can still cause small differences in rare situations. In contrast, A is wrong because it claims universal batch sizes and perfect repeatability. Likewise, B is wrong because learning rate and epochs are tunable settings, not fixed constants across all jobs. Finally, C is wrong because seed does not control quota or region, and epochs relate to training iterations, not deployment speed. Question 14. For each statement below, indicate whether the answer is true or false. Function calling lets an agent decide which custom function to invoke and return the function plus arguments. True. Azure functions rely on triggers for execution timing and bindings to connect to data sources. True. Open API-based tools are used to describe HTTP APIs, which helps generate client code and tests. True. Azure Logic Apps is a high-code approach that requires writing custom compiled handlers for every connector. False. Let's connect each statement to what these technologies actually do in practice. First, the function calling statement is true because the agent can select the appropriate function and supply structured arguments, so your app can execute the right action without you hard-coding every possible path. Next, Azure Functions using triggers and bindings is true because triggers determine when the function runs, while bindings simplify input and output connections to services like storage, queues, or databases. Additionally, the OpenAPI statement is true because OpenAPI provides a standard way to describe HTTP endpoints, which makes it easier to generate client SDKs, validate requests, and even scaffold tests. However, the Logic Apps statement is false because Logic Apps is designed as a low-code or no-code workflow service with built-in connectors, so you typically configure integrations rather than writing custom compiled handlers for each connector. Fill in the blanks by selecting the correct options from the drop-down menus. An Azure AI Foundry agent acts as a self-contained runtime that provides enterprise-level features, such as secure memory management, function execution, and automatic tool invocation. We've completed the sentence, so let's quickly justify why each filled phrase is the best fit. First, self-contained runtime fits because the agent comes with an integrated execution environment, so it's not just a prompt, it's a runtime that can manage actions and context. Next, enterprise-level features fits because the agent framework is designed for business-grade needs like secure operation, planning, and managed memory behavior. Finally, automatic tool invocation fits because the agent can call tools and functions automatically using the framework's structured calling mechanism without you manually parsing text and wiring each call by hand. Fill in the blanks by selecting the correct options from the drop-down menus. The Microsoft Agent Framework allows developers to integrate AI models into applications using an open-source SDK. With the sentence in place, here's why those two phrases fit the intent of the framework. First, integrate AI models works because the framework's primary purpose is to help you embed AI capabilities directly into an application, so the app can call models as part of its normal workflows. Additionally, open-source SDK works because it highlights that the tooling is publicly available and extensible, meaning developers can adopt it, customize it, and build on it rather than being locked into a closed library. Question 17. For each statement below, indicate whether it is true or false. All orchestration patterns in the SDK use a consistent development model for building and running workflows. True. Developers must learn a different API for each orchestration pattern. False. The SDK's orchestration framework allows agents to share the same interface for construction and invocation. True. Manual orchestration of agent communication is a required step in building workflows. False. Let's translate those statements into what you experience as a developer using the SDK. First, the consistent development model statement is true because the SDK is designed so patterns plug into a unified approach for building and running workflows, which keeps your development experience consistent. However, the idea that you must learn a different API for every pattern is false because the goal is to reduce fragmentation and let you work through a shared interface rather than switching mental models each time. Additionally, it's true that agents can share the same interface for construction and invocation, which simplifies setup and execution across patterns. Finally, manual orchestration being required is false because the SDK is intended to automate coordination, so you are not forced to hand-wire every agent-to-agent interaction just to make a workflow run. Question 18. For each core component of an A2A agent server, drag it to its correct description. Each item may be used once, more than once, or not at all. Describes the agent's capabilities, skills, and input-output modes. Agent card. Routes incoming requests to appropriate executor methods. Request handler. Built using a web framework to handle HTTP requests. Server application. Tracks tasks, streaming data, and resubscriptions, request handler. Exposed at a standard endpoint, /.wellknown/agentcard.json. Agent card. Uses an ASGI server like Uvicorn to start listening on a network interface. Server application. We've placed each component, so now let's make the roles of these pieces feel concrete. First, the agent card is the discoverability layer because it describes what the agent can do, what skills it exposes, and how it accepts inputs and returns outputs. Additionally, it is published at a standard endpoint, which is why other agents or clients can fetch it and understand how to interact with this server. Next, the request handler is the traffic director because it receives incoming A2A calls and routes them to the right execution methods. And it also manages workflow concerns like tracking tasks, handling streaming updates, and supporting resubscriptions when a client reconnects. Finally, the server application is the hosting layer because it's the actual web app built on a framework to process HTTP requests and expose the required endpoints. And it typically runs behind an ASGI server such as Uvicorn that listens for network traffic. Question 19. For each statement, indicate true or false. Foundry Agent Service is more streamlined and secure than building agents directly on the Inference API. True. You must always use platform-managed storage. Bringing your own Azure Blob Storage isn't supported. False. Basic agent setup includes Azure AI Hub, Azure AI Project, and Azure AI Services. True. Standard agent setup adds Key Vault, Azure AI Search, and Azure Storage to the basic setup. True. Let's connect each statement to what it means when you're designing an agent solution. First, this is true because Foundry Agent Service abstracts a lot of the heavy lifting around agent setup and helps you apply security and operational best practices compared with wiring everything directly against the raw Inference API. However, the storage statement is false because storage is flexible, meaning you can use platform-managed storage or bring your own Azure Blob Storage depending on your architecture and control requirements. Next, the basic setup statement is true because the minimal foundation is the hub for governance, the project for your working context, and Azure AI services to power the capabilities. Finally, the standard setup statement is also true because it extends the base with Key Vault for secrets management, Azure AI Search for retrieval and grounding, and Azure Storage for persistent data, which is the typical pattern when moving from a minimal build to a production-ready design. Question 20. Arrange the steps for enabling MCP-based dynamic tool discovery in an AI agent. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Start an MCP server that exposes functions as tools with that mcp.tool. Connect an MCP client to the server. Fetch the tool list and generate function wrappers. Add the wrappers to the Azure AI agent's tool definitions. Handle a user request by invoking discovered tools as needed. We've set the order. Now let's link each step to the dependency it satisfies. First, you start the MCP server and expose functions with that mcp.tool because nothing can be discovered until the tools are actually published. Next, you connect an MCP client to the server, establishing the communication channel the agent relies on to query what tools exist. Then, you fetch the tool list and generate function wrappers, which converts the discovered tool metadata into callable functions your agent can use programmatically. After that, you add those wrappers to the Azure AI agent's tool definitions, so the agent runtime knows these tools are available during reasoning and execution. Finally, when a real user request comes in, the agent can invoke the discovered tools dynamically as needed, just using the wrappers and definitions you registered earlier. Question 21. A platform team wants its Azure AI agent to use new data quality tools the moment they're published without redeploying the agent. Tool definitions must be maintained centrally, and each tool call should run via an async function the agent can invoke as if it were native. Which approach best satisfies these requirements? Select one answer. A. Place tool stubs in a separate microservice and have the agent guess which endpoint to call. B. Create a static dictionary and code mapping tool names to URLs and redeploy the agent when tools change. C. Use an MCP server with fastMCP to host tool definitions. Discover them with an MCP client via session.list tools. Wrap each in an async function that calls session.callTool, then bundle them into function tool and register with the agent. D. Embed all tool logic into the agent prompts and rely on the model to generate HTTP requests directly. The correct answer is C. Use an MCP server with fastMCP to host tool definitions. Discover them with an MCP client via session.list tools. Wrap each in an async function that calls session.callTool, then bundle them into function tool and register with the agent. Let's connect the requirements to the mechanics of the solution. First, central management is satisfied because the MCP server becomes the single place where tool definitions live and are published, so updates happen once and become available to clients immediately. Next, zero redeploy is satisfied because the agent discovers tools at runtime through session.list tools, so you are not baking tool lists into the agent's code. Additionally, native-like invocation is satisfied by generating wrappers that look like normal async functions to the agent, while the actual execution happens through session.callTool behind the scenes. Finally, registering those wrappers as function tool is what makes the tools appear as first-class entries in the agent's toolset, so the agent can select and call them reliably. In contrast, A and D rely on guessing or prompt-based calling, which removes structured discovery and safe invocation. Likewise, B defeats the goal because it forces redeployment whenever tools change. Question 22. A developer is building an AI assistant with Azure AI Foundry agent. They want to minimize manual effort in tracking previous messages and maintaining context. Which feature helps achieve this goal? Select one answer. A. Manual database logging for each user message. B. Automatic thread-based state management that maintains conversation history. C. Local file storage for conversation records. D. Reinitializing the agent for every new question. The correct answer is B. Automatic thread-based state management that maintains conversation history. Let's connect that directly to the problem of context in a chat assistant. First, automatic thread-based state management keeps the conversation history attached to the thread so the agent can remember prior turns without the developer manually storing and replaying messages on every call. Additionally, it reduces boilerplate because context handling becomes part of the agent runtime, rather than something you build and maintain yourself. In contrast, manual database logging or local file storage adds extra work and is not required just to maintain conversational continuity. Finally, reinitializing the agent for every question defeats the goal because it throws away context and forces the assistant to start from scratch each time. Question 23. An orchestration system generates a comprehensive output that includes both the step-by-step reasoning plan and the resulting solution. What key characteristic does this demonstrate? Select one answer. A. Integration of documented planning with the final solution. B. Focusing solely on the fastest task completion. C. Manual assembly of separate reports after execution. D. Execution of independent agents without shared context. The correct answer is A. Integration of documented planning with the final solution. Let's connect the clue in the question to the idea it's testing, because the output includes both the plan and the final solution in one package. It demonstrates that planning is produced and recorded during execution, then carried through into the final deliverable. Consequently, this reflects an orchestration style that values traceability and explainability alongside completion. In contrast, option B focuses on speed, which does not require preserving a documented plan. Similarly, option C is wrong because the plan is not being stitched together manually afterward. It's generated as part of the run. Finally, option D is wrong because a unified plan and solution implies shared context and coordinated execution, not isolated agents working independently. Question 24. Which two statements are true about using remote MCP servers with Azure AI agents? Select two answers. A. The agent can connect to multiple MCP servers by adding each as a separate MCP tool entry with its own server label and server URL. B. When using the Azure MCP tool, developers must still wrap tools and call session.call tool manually. C. Approval mode defaults to always, requiring developer approval for each MCP tool call unless changed. D. Headers set with update headers are stored and reused automatically in later runs. The correct answers are A and C. Now let's walk through why those two are the true statements. First, A is true because Azure AI agents can be configured to talk to more than one MCP server, as long as each server is added as its own MCP tool entry with its own server label and server URL, which makes multi-server discovery and routing possible. Additionally, C is true because approval mode defaults to always, meaning the agent will request developer approval for each MCP tool call unless you explicitly change that setting. However, B is false because the Azure MCP tool is designed to avoid manual wrapping and direct session.call tool handling in this model. Likewise, D is false because headers added through update headers are provided for the current run as tool resources and are not persisted and reused automatically in later runs. Question 25. What is one benefit of reusing an existing agent thread instead of creating a new one? Select one answer. A. It forces the agent to restart conversation logic each time. B. It allows the agent to maintain conversation context across multiple interactions. C. It disables memory tracking for performance reasons. D. It prevents access to previous message history. The correct answer is B. It allows the agent to maintain conversation context across multiple interactions. Let's connect that to what an agent thread represents in a real chat experience. Reusing an existing agent thread preserves the prior messages and state tied to that thread, so the agent can continue the conversation naturally without you rebuilding context on every turn. As a result, follow-up questions make sense, references to earlier details stay available, and the user experience feels continuous rather than starting over each time. In contrast, option A describes what happens when you create a new thread, not when you reuse one. Similarly, option C is incorrect because thread reuse does not disable memory tracking. It enables continuity. Finally, option D is the opposite of the benefit because reusing the thread is what keeps access to prior message history available. Question 26. Which statement describes a best practice for handling errors when developing custom tools for an AI agent? Select one answer. A. Ignore errors to allow the AI to decide how to fix them automatically. B. Implement appropriate error handling so the tool can gracefully handle unexpected inputs. C. Replace error messages with random default outputs to prevent conversation interruptions. D. Disable exceptions to simplify the tool's function logic. The correct answer is B. Implement appropriate error handling so the tool can gracefully handle unexpected inputs. Let's connect that to reliability in real tool execution. When a custom tool validates inputs and handles exceptions cleanly, it can return structured, usable error responses instead of crashing, which helps the agent recover and continue the workflow intelligently. As a result, the agent can prompt for corrected parameters, retry safely, or choose an alternative path without breaking the conversation. In contrast, ignoring errors reduces reliability because the agent receives incomplete or misleading signals. Likewise, returning random default outputs hides the real issue and can produce incorrect results. Finally, disabling exceptions removes safeguards, making the tool unstable and harder to debug in production. Question 27. Which feature listed under an agent's capabilities allows it to send information to another agent without waiting for a request? Select one answer. A. Input-output mode. B. Push notification support. C. Endpoint URL. D. Agent version. The correct answer is B. Push notification support. Let's connect that to how proactive communication works between agents. Push notification support enables an agent to send updates proactively, meaning it can publish information to another agent as soon as something changes, without waiting to be queried first. For example, if a long-running task finishes, the agent can notify downstream agents immediately so the workflow continues. In contrast, input-output mode only describes supported formats, not when messages are sent. Similarly, an endpoint URL is just the address for access, not a capability for proactive delivery. Finally, agent version is simply revision metadata and does not affect how the agent communicates. Fill in the blanks by selecting the correct options from the drop-down menus. Before publishing, a knowledge base should be tested interactively in Language Studio by reviewing returned answers and confidence scores. We've completed the full sentence. Now let's clarify what each checking before you publish. Tested interactively fits because you want to run real sample questions and confirm the knowledge base is responding correctly before it goes live. Additionally, Language Studio fits because it provides the built-in environment for trying queries and inspecting the responses without writing extra code. Finally, confidence scores fits because those scores help you judge how strongly the system matched the question to the returned answer, so you can spot weak matches and improve your content or tuning before release. Question 29. For each statement below, indicate whether it is true or false. Active learning is enabled by default. True. Users can review and accept or reject alternate question suggestions. True. Synonyms are created in Language Studio through a graphical interface. False. Synonyms allow the system to treat different words with the same meaning as equivalent. True. Let's connect each statement to how question-answering knowledge bases are maintained. First, active learning being enabled by default is true because the system can automatically suggest improvements as the knowledge base is used, supporting ongoing optimization. Next, it's true that users can review and accept or reject alternate question suggestions because those suggestions are meant to be curated so you can approve them individually or in bulk. However, the synonym statement about a Language Studio graphical interface is false because synonyms are defined through the REST API rather than created directly in the Language Studio UI. Finally, the meaning of synonym statement is true because synonyms help the system treat equivalent terms as the same intent, so users can ask with different wording and still get the correct answer. Fill in the blanks by selecting the correct options from the drop-down menus. The REST payload for a single label custom classification project sets project kind to custom single label classification in both the metadata and assets sections, while the string index interpretation is specified by UTF-16 code unit. We've completed the sentence. Now let's tie each blank to what it controls in the payload. First, custom single label classification fits because it is the project kind value that explicitly identifies the project as single label classification, not multi-label. Next, metadata fits because that is one place where the payload declares the project kind for the project definition. Additionally, assets fits because the project kind value is mirrored there as well, keeping the project configuration consistent across sections. Finally, UTF-616 code unit fits because that is the string index type setting that defines how text offsets are computed and interpreted when the service processes the content. Question 31. For each Azure AI translator function, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Detects the language of text via the /detect API version equals 3.0 endpoint. Detect translates text using from equals source and one or more to equals target. Translate converts writing systems using from script equals JPAN and to script equals Latin. Transliterate. We've matched each function to its purpose, so now let's make the differences easy to remember. First, detect is the option that identifies the language of the input text, which is why it aligns with the /detect endpoint. Next, translate is the option that converts meaning from one language to another, so it uses from and one or more to parameters to produce translations. Finally, transliterate keeps the meaning the same, but changes the writing system, like rendering Japanese script into Latin characters using from script and to script. Consequently, items like sentiment analysis and summarize stay unused because they are not functions provided by the translator endpoints in this context. Question 32. For each text-to-speech feature, drag it to the correct description. Each item may be used once, more than once, or not at all. Provide speech synthesis for short, real-time conversations from text to audio. Text-to-speech API. Designed for converting large volumes of text to audio, such as audiobooks. Batch Synthesis API. Used primarily by interactive applications through a programming SDK rather than direct REST calls. Azure AI Speech SDK. We've placed the matches, now let's make the intent behind each choice clear. First, the text-to-speech API fits short, real-time synthesis because it is the primary endpoint for turning text into audio on demand, like generating a spoken reply in a live assistant. Next, the batch synthesis API fits large volumes because it is optimized for bulk jobs, such as converting many chapters into audiobook-style narration without needing real-time responsiveness. Finally, the Azure AI Speech SDK fits interactive apps because developers often use the SDK inside applications to handle speech synthesis flows directly in code, instead of composing raw REST calls each time. Consequently, speech-to-text and intent recognition stay unused here because they focus on understanding audio, not generating it. Question 33. A data team trained a custom NER model but noticed that loan amount and account number are often confused. What should they do next? Select one answer. A. Add more distinct examples of each entity type to training data. B. Reduce the number of entity types. C. Merge both entities into one combined type. D. Redeploy the model without retraining. The correct answer is A. Add more distinct examples of each entity type to training data. Here's the most direct way to fix that kind of confusion in NER. If two entities are being mixed up, it usually means the model has not seen enough clear diverse examples that separate them during training. So adding more distinct training samples for loan amount versus account number, with consistent labeling and varied contexts, helps the model learn the boundary between the two. In contrast, reducing entity types or merging them makes the model less useful because you lose the distinction you actually need. Likewise, redeploying without retraining will not change the learned patterns, so the confusion will remain. Question 34. Arrange the following steps involved in evaluating a language model's entity recognition performance in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Analyze model precision and recall scores. Review the F1 score for combined performance. Inspect the confusion matrix for detailed errors. Add or adjust training data and labels to improve results. We've set the sequence. Now let's connect why this order is the most logical evaluation flow. First, you start with precision and recall, because they tell you how accurate the entity predictions are and how complete the model is at finding entities. Next, you review the F1 score because it combines precision and recall into a single balanced metric, giving you a quick summary of overall performance. Then, you inspect the confusion matrix to see exactly which entity types are being mixed up, which highlights the specific failure patterns behind the scores. Finally, once you know the error trends, you add or adjust training data and labels to target those weaknesses and improve the next training run. Question 35. For each statement below, indicate whether it is true or false. Adding more labeled data can improve model performance accuracy. Correct answer is true. The View Model Details page shows scores for each entity and for the overall model. Correct answer is true. A confusion matrix provides textual explanations of entity errors. Correct answer is false. The left-hand pane in Language Studio allows access to model scoring. Correct answer is true. Now that we've covered every statement and the correct answers, let's walk through why each one makes sense. First, adding more labeled data usually improves accuracy because the model sees more examples and learns clearer patterns. Next, the View Model Details page is where you typically find both per entity scores and an overall score, so true fits there. However, a confusion matrix is mainly a structured comparison of predicted versus actual labels. It highlights where the model gets confused, but it does not provide written explanations by itself, so that statement is false. Finally, the left-hand pane in Language Studio is your navigation hub, and that's where you access evaluation and scoring pages, which is why the last statement is true. Question 36. A developer uploads a voice recording of a customer question and includes additional written context in the same message while testing a model in the Azure AI Foundry chat playground. The developer wants the model to interpret both the audio and text together to produce a single response. Which capability makes this possible? Select one answer. A. The model's multimodal input processing. B. The chat playground's text-only interaction mode. C. The Azure AI Foundry documentation feature. D. The speech-to-text preprocessor converting all messages. The correct answer is A. The model's multimodal input processing. Let's connect the requirement, understanding audio and text together, to the capability that enables it. Multimodal input processing allows a model to take different input types in one prompt, such as audio plus text, and fuse them into a single understanding before generating one coherent answer. In contrast, a text-only interaction mode cannot interpret audio alongside text. Similarly, documentation features provide reference material, not runtime processing. Finally, a speech-to-text preprocessor is not the core capability here, because the model can directly reason over multiple modalities rather than relying only on a transcript pipeline and a transcript processor. Question 37. For each statement below, indicate whether it is true or false. Prompts for audio-based chat must include both text and audio content. True, the audio content item can only reference external URLs. False, binary audio data can be encoded in base64 format. True, JSON structure for prompts cannot include multiple roles such as system and user. False, let's connect each statement to how audio-enabled prompts are structured. First, this is true because audio chat prompts commonly include both the audio input and accompanying text, so the model can combine modalities when producing one response. However, it's false that audio can only come from external URLs because audio can also be provided as local binary data encoded into the request, not just linked remotely. Next, it's true that binary audio can be encoded in base64, which is a standard way to embed binary content into JSON safely. Finally, it's false that JSON prompts cannot include multiple roles, because structured prompts regularly include roles like system and user to control behavior and provide conversational context. Question 38. How can multi-turn responses be enabled when creating a knowledge base? Select one answer. A, through Microsoft Entra ID settings. B, by configuring Azure Bot Intents directly. C, automatically when importing FAQs or manually by defining follow-up prompts. D, only by adding custom code in the REST API. The correct answer is C. Automatically when importing FAQs or manually by defining follow-up prompts. Let's connect multi-turn behavior to how knowledge bases are authored. Multi-turn responses are enabled when your knowledge base content includes follow-up prompts, either because the FAQ import brings in a structured multi-step flow, or because you manually add follow-up prompts to an existing Q&A pair. As a result, the system can guide the user through a sequence of related questions instead of returning a single one-off answer. In contrast, Entra ID controls identity and access, not conversational structure. Likewise, bot intents are part of language understanding, not the question-answering knowledge base configuration. Finally, you do not need custom REST code just to enable multi-turn, because the portal and import process already support it directly. Question 39. What is the purpose of the ID field in the JSON response from a knowledge base? Select one answer. A, it specifies the type of metadata attached to the answer. It uniquely identifies the question-answer record that produced the response. C, it defines the maximum number of answers to return. D, it determines the minimum confidence level for answers. The correct answer is B. It uniquely identifies the question-answer record that produced the response. Let's connect that ID field to how knowledge base answers are tracked. The ID is the internal identifier of the matched question and answer pair, so you can trace exactly which stored record produced the returned answer, which is useful for auditing, updates, and feedback loops. In contrast, metadata type is handled by separate metadata fields, not the ID. Likewise, the maximum number of answers is controlled by request settings, such as top, not the response ID'd. Finally, minimum confidence is controlled by a threshold setting like score threshold, not by the ID value. Question 40. A voice developer wants to simulate a conversational exchange between two neural voices, one cheerful and one neutral, pronouncing the same word differently. The cheerful voice should say, I say tomato, and the other should say I say tomatu. Which configuration will achieve this? Select one answer. A. Change the XML lang attribute for each sentence to alternate speakers. B. Set the speech synthesis output format to RIF 24 Khertz 16-bit mono PCM. Use two voice elements in a single SSML document, each with distinct voice names and styles. Duplicate the MSTTs express as style inside one voice element. The correct answer is C. Use two voice elements in a single SSML document, each with distinct voice names and styles. Let's connect the requirement, two different speakers in one output, to the SSML mechanism that supports it. Using two separate voice elements lets you define two distinct neural voices and apply different styles, so the SSML can alternate speakers and produce a dialogue like a real conversation. For example, one voice element can be set to a cheerful style, while the other voice element uses a neutral tone, and each speaks its own line in sequence. In contrast, XML lang only changes the language tag, not which speaker voice is used. Likewise, the output format controls audio encoding quality, not multi-speaker behavior. Finally, duplicating MST Express as inside one voice element cannot create two separate speakers, because a single voice element represents only one voice identity at a time. Question 41. What are two supported authentication methods for accessing the VoiceLive API? Select two answers. A. Microsoft Entra Keyless Authentication. B. OAuth 2.0 Implicit Grant Only. C. API Key Authentication. D. Shared Access Signature SaaS Token. The correct answers are A. Microsoft Entra Keyless Authentication, and C. API Key Authentication. And finally, let's connect each correct method to how you would actually call the VoiceLive API. First, Microsoft Entra Keyless Authentication is supported because it lets you access the API using Azure Identity and Role-Based Access, which is ideal for production apps that want managed credentials instead of embedded secrets. Additionally, API Key Authentication is supported because you can include an API key when making requests, which is a straightforward approach for service-to-service calls and quick testing. In contrast, OAuth 2 Implicit Grant Only is not the required model here because Entra token-based access is broader than that single flow. Finally, SaaS tokens are primarily for Azure storage resources, not for authenticating to the VoiceLive API itself. Question 42. A media production studio wants to integrate virtual presenters using the VoiceLive API with realistic lip sync animation. The visuals appear pixelated during streaming. What should the developers do to improve video quality? Select one answer. A. Use high-resolution settings for the avatar's video configuration. B. Enable REST polling for smoother playback. C. Reduce video bitrate and resolution to lower latency. D. Increase the silence duration milliseconds parameter in turn detection. The correct answer is A. Use high-resolution settings for the avatar's video configuration. Let's connect pixelation to the setting that directly controls visual fidelity. Pixelation is a quality issue, so the direct fix is increasing the avatar video resolution, which improves sharpness and realism during streaming. In contrast, REST polling is not designed for real-time video playback. Likewise, reducing bitrate and resolution would typically make pixelation worse, not better. Finally, silence duration in turn detection affects speech turn detection timing, not how video is rendered or encoded. Question 43. When preparing a request for key phrase extraction, which two statements are true? Select two answers. A. The maximum size for any document is 5,120 characters. B. A request can include multiple documents for analysis. C. Each document must include a country hint property. D. The response returns a confidence score for each phrase. The correct answers are A. The maximum size for any document is 5,120 characters, and B. A request can include multiple documents for analysis. Let's connect those choices to how the key phrase extraction request is structured. First, A is true because each document you submit must stay within the maximum size limit, so large inputs need to be split before sending. Next, B is true because the API supports batching, meaning one request can carry multiple documents for analysis in a single call. However, C is false because a country hint value is not mandatory for key phrase extraction. It is only relevant in specific scenarios like language detection hints. Finally, D is false because key phrase extraction returns the extracted phrases, not a confidence score per phrase, as part of the standard output. Question 44. Which field inside evaluation options determines whether the data split is handled automatically or manually? Select one answer. A. Kind. B. Training config version. C. Model label. D. Training split percentage. The correct answer is A. Kind. Let's connect that field to the split behavior it controls. The kind field specifies the split type, for example using percentage for an automatic split or set for a manual split. In contrast, training config version describes the training configuration version, not how the data is split. Similarly, model label is a naming or identification field, not a splitting control. Finally, training split percentage only provides the numeric ratio once you have chosen a percentage-based split, but it does not decide whether the split is automatic or manual in the first place. Question 45. Which statement correctly describes the role of the text-to-speech REST API documentation? Select one answer. A. It explains how to configure voice styles within the Azure portal settings. B. It provides detailed information for making direct HTTP requests to perform speech synthesis without using an SDK. C. It is required for installing the Speech SDK package for Python. D. It lists billing rates for audio generation across Azure regions. The correct answer is B. It provides detailed information for making direct HTTP requests to perform speech synthesis without using an SDK. Let's connect what REST documentation is meant to do to the options you see here. Text-to-speech REST API documentation focuses on request and response details, including endpoints, headers, payload formats, and returned results, so developers can call the service directly over HTTP without relying on an SDK. In contrast, portal voice style setup is handled through tooling and configuration experiences rather than the REST reference itself. Likewise, installing the Speech SDK is a separate package management step unrelated to REST documentation. Finally, pricing details live in Azure pricing documentation, not in the API reference for text-to-speech. Question 46. For each visual features member, drag it to its corresponding description in the correct match column. Each item may be used once, more than once, or not at all. Generates a concise natural language sentence summarizing image content. Visual features.caption. Returns bounding boxes for every detected object. Visual features.objects. Identifies tags that describe scenery, objects, or actions in the image. Visual features.tags. Returns bounding boxes for detected people. Visual features.people. We've matched the features. Now let's clarify what is included versus left out. Caption is the feature that produces a short human-readable sentence describing the overall scene. Objects is the feature that detects items and returns their coordinates as bounding boxes. Tags is the feature that outputs descriptive keywords for what appears in the image, such as scenery, objects, or actions. People is the feature specialized for detecting people and returning bounding boxes for their positions. Consequently, read stays unused because it extracts printed text, not scene description. Likewise, smart crop stays unused because it generates cropped regions for composition, not tags, captions, or detection results. Question 47. A bank's mobile app allows users to log in by scanning their face. To prevent people from holding up printed photos or videos, which Face API capability should the app implement? Select one answer: A, face detection; B, facial liveness; C, facial landmark location; D, quality for recognition. The correct answer is B, facial liveness. Let's connect the threat, spoofing with photos or replayed video, to the capability that blocks it. Facial liveness is designed to verify that the input comes from a real live person in front of the camera, rather than a printed image, a mask, or a replayed video. In contrast, face detection only confirms a face is present, not that it is real time. Similarly, landmark location only returns facial coordinates and does not validate authenticity. Finally, quality for recognition measures image suitability for recognition, not whether the subject is live. Question 48. For each statement below, indicate whether the answer is true or false. Organizations using facial data should implement governance to ensure accountability. True, consent from users is optional when collecting personally identifiable facial data. False, facial data should be retained indefinitely to improve model training. False, the Azure Face API includes built-in measures that follow responsible AI principles. True? Let's connect each statement to responsible use of biometric systems. First, governance and accountability are required because facial data is high risk, so oversight, auditing, and clear ownership help ensure ethical and compliant handling. However, consent being optional is false because identifiable biometric data requires explicit, informed consent in responsible practice. Next, indefinite retention is also false because keeping facial data longer than necessary increases privacy and security risk, so retention should be limited and justified. Finally, the Face API safeguard statement is true because the service includes built-in responsible AI measures intended to support ethical and compliant use. Question 49. For each Azure AI custom vision prediction time input, drag it to the description it fulfills. Each item may be used once, more than once, or not at all. Identifies which custom vision project to use for predictions. Project ID. Selects the specific published iteration to run. Published model name. Provides the credential used to authorize prediction requests. Prediction resource key. Specifies the base URL of the prediction endpoint to call, prediction resource endpoint. We've completed the matching. Now let's connect each input to what it controls at prediction time. Project E tells the service which project's trained model family you are targeting. Published model name selects the exact published iteration, meaning the specific version you want the prediction endpoint to execute. Prediction resource key is the credential that authenticates the request to the prediction endpoint. Prediction resource endpoint is the base URL your client sends prediction calls to. Consequently, training resource key is not used here because it applies to training operations, not runtime predictions. Likewise, a storage account connection string is unrelated to calling the custom vision prediction API. Fill in the blanks by selecting the correct options from the drop-down menus. To train an object detector without writing code, upload images and label them using the interactive labeling interface in the Custom Vision portal. After labeling an initial batch and completing a first training, the Smart Labeler can suggest both regions and likely classes on new images. We've completed the full sentence. Now let's connect each blank to what it does in the workflow. The interactive labeling interface is the portal-based tool you use to draw bounding boxes and assign tags to objects, which is how you build training data without code. After you run an initial training, the Smart Labeler can use what the model has learned to propose bounding boxes and predicted labels for new images, helping you label faster while you review and confirm the suggestions. Question 51. Which statement about invoking OCR via REST is accurate? Select one answer. Use // image analysis : analyze ? features equals read to request OCR results. B. Use // image analysis : analyze ? features equals dense captions to extract text. C. The OCR endpoint accepts only base64 strings, never image URLs. D. OCR can be requested only from the .NET SDK, not REST. The correct answer is A. Use // image analysis : analyze ? features equals read to request OCR results. Now let's connect that endpoint parameter to what the service actually runs. When you pass features equals read, you are explicitly telling the image analysis API to run the read capability, which is the OCR function that extracts text from the image. In contrast, dense captions generates descriptive captions about the scene rather than extracted text, so it does not represent OCR output. Additionally, it is not true that only base64 is accepted, because OCR requests can be made using either uploaded image bytes or a publicly accessible image URL, depending on the API call format. Finally, OCR is not limited to the .NET SDK because the same functionality is available through REST as well as multiple SDKs. Question 52. Your team used a third-party labeling tool that exports bounding boxes in absolute pixels. You need to train and then serve an object detector using an API that expects proportional 0 to 1 values with the origin at the top left. What should you do before sending labels to the API? Select two answers. A. Convert all box coordinates and sizes by dividing by the image width or height as appropriate. B. Switch to image level tags only and drop all regions. C. Keep pixel values. The service converts them automatically. D. Ensure left maps to the horizontal offset from the left edge and top maps to the vertical offset from the top edge. The correct answers are A and D. Now let's connect the API's expected coordinate system to the pre-processing steps you must take. First, A is required because the API expects normalized values between 0 and 1, so you must convert pixel-based left, top, width, and height into proportions by dividing horizontal measures by image width and vertical measures by image height. Next, D is required because the origin is the top left, so left must remain the horizontal offset from the left border, and top must remain the vertical offset from the top border. Otherwise, boxes can shift or flip when interpreted by the service. In contrast, switching to image-level tags removes regions and turns the task into classification, not detection. Likewise, keeping pixel values is incorrect because the API expects normalized coordinates and does not rely on implicit automatic conversion. Question 53. Identify the pair that correctly matches a video indexer feature with its purpose. Select one answer. A. Topics rates the emotional tone of speech. B. Labels assigns descriptive tags to recurring objects' themes. C. Scene segmentation detects specific people's identities. D. Content moderation converts spoken audio to text. The correct answer is B. Labels assigns descriptive tags to recurring objects' themes. Now let's connect each feature name to what it actually produces in Video Indexer. Labels are used to tag notable objects, scenes, or themes that appear across the video, which is why they map directly to descriptive tags. In contrast, topics are about identifying discussion subjects, while emotional tone is handled by sentiment style analysis, not the topics feature. Similarly, scene segmentation divides a video into scene boundaries, but identifying people is handled by face or person-related analysis, not segmentation. Finally, content moderation is meant to flag potentially sensitive content, whereas converting speech to text is done by transcription, not moderation. Question 54. A research lab is developing a generative assistant that analyzes uploaded photographs and provides written summaries. They've already selected a model from the Azure AI Foundry catalog. What's the next step to begin interacting with this model using both text and image prompts? Select one answer. A. Deploy the model in Azure AI Foundry to enable testing and interaction. B. Install local GPU drivers to run the model offline. C. Convert the model catalog entry to a static HTML file. D. Download sample images from Azure Storage. The correct answer is A. Deploy the model in Azure AI Foundry to enable testing and interaction. Now let's connect model selection to what actually makes the model usable in an application. Selecting a model in the catalog is like choosing the engine. Deployment is what turns that choice into an active endpoint you can send requests to, including multimodal prompts that contain both images and text. In contrast, local GPU drivers are unnecessary because the model is hosted and managed in Azure, not run locally. Likewise, converting a catalog entry to HTML does not create an endpoint or enable inference. Finally, sample images can help you test later, but downloading them does not enable interaction until the model is deployed and accessible. Question 55. Arrange the steps involved in preparing to use Azure Document Intelligence in the correct sequence. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Subscribe to an Azure AI Services or Azure Document Intelligence resource. Collect or prepare the form files for analysis. Choose the appropriate Document Intelligence component, layout, pre-built, or custom. Submit documents for extraction and receive structured output. We have the correct sequence. Now let's walk through why it must flow in that order. You start by subscribing to the resource because that's what gives you access, authentication, and the endpoint to call. Next, you collect or prepare the documents because the service cannot analyze anything until the inputs are ready and they're set. After that, you choose the right component because layout, pre-built, and custom serve different extraction needs, depending on the document type and goal. Finally, you submit the documents, and that's when the service runs extraction and returns structured results. Question 56. A search engineer wants to modify how indexed field names appear in query results without changing the original data source field names. Which field mapping strategy should they use? Select one answer. Default schema mapping. B. Dynamic mapping. C. Implicit mapping. D. Explicit mapping. The correct answer is D. Explicit mapping. Now let's connect the goal, renaming fields in the index output, to the mapping behavior. Explicit mapping is the option that lets you define source-to-index field mappings with custom target field names, so the index can expose cleaner or more user-friendly field names and results without touching the original source schema. In contrast, implicit mapping only works when names already match and does not rename or transform fields. Dynamic mapping is not the strategy used here for controlling field names, because you need a deliberate mapping definition to change what appears in the index. Default schema mapping is not the mechanism for customizing index field names in this scenario. Question 57. Fill in the blanks by selecting the correct options from the drop-down menus. In a JSON analyzer definition, the base analyzer ID specifies the pre-built analyzer on which the schema is based, while field schema lists the fields to extract or generate from content. Now let's tie each blank to what it controls in the analyzer definition. Base analyzer ID is the pointer to the underlying pre-built analyzer you are extending, so it answers the question, what base analyzer is this schema built on? Meanwhile, field schema is where you declare the schema itself, and inside that schema, you define the fields the analyzer should extract or generate, which is why it completes the idea of listing what gets pulled or inferred from the content. Question 58. For each mortgage document, drag it to its immutable form identifier. Each item may be used once, more than once, or not at all. Uniform residential loan application matches Form 1003. Appraisal matches Form 1004. Verification of employment matches Form 1005. Uniform Underwriting and Transmittal Summary Matches, Form 1008. All right, with the correct matches in place, here's why they fit. First, these form numbers are standardized identifiers in the mortgage workflow, so the loan application is consistently tied to Form 1003. Next, the appraisal report is the standard Form 1004, which is why it pairs directly with appraisal. Additionally, employment verification maps to Form 1005 because it's the dedicated document for confirming a borrower's job and income details. Finally, the underwriting and transmittal summary aligns with Form 1008 since that's the common format used to summarize the loan file for submission. Therefore, items like Form W-2 and Form 1099 don't match any of these specific mortgage document types here. Question 59. For each statement below, indicate whether the answer is true or false. The business card model can extract a postal address in addition to names, email, website, and phone numbers. True. The invoice model returns line item product codes along with description, quantity, unit price, tax, and line total. True. The ID document model reports the country region of issuance for supported IDs. True. The receipt model focuses on amounts charged rather than amounts paid. False. Now that we've locked in the true and false choices, let's walk through what each model is designed to return. Firstly, business cards commonly include a physical address, so the business card model is built to extract that alongside contact fields. Moreover, invoice extraction is intentionally detailed, which is why it captures line items like product codes, quantities, unit prices, taxes, and totals for each row. Next, ID document analysis includes metadata about the ID itself, so reporting the issuing country or region is part of the expected output for supported documents. Finally, receipts are evidence of payment, so they emphasize amounts paid, not outstanding charges. Therefore, saying they focus on amounts charged is the incorrect statement. Question 60. Which configurations are valid when submitting binary content for analysis? Select 3 answers. A. Set the content type header to application octet stream. B. Include a .pdf or PNG file as binary data in the post body. C. Specify an MP3 or MP4 file for audio or video analysis. D. Send a JSON schema file as content to be analyzed. E. Omit the content type header when posting binary data. The correct answers are A. Set the content type header to application octet stream. B. Include a PDF or PNG file as binary data in the post body. C. Specify an MP3 or MP4 file for audio or video analysis. After reviewing all the options and the correct selections, let's break down why these choices work. Firstly, application octet stream signals that the payload is raw binary, so the service can process it properly. Next, PDF and PNG are common supported formats, so sending them as binary in the post body matches the expected input style. Additionally, when audio or video analysis is supported, MP3 and MP4 can also be uploaded as binary for processing. In contrast, a JSON schema file describes configuration, not the content being analyzed. Likewise, omitting content type can cause the request to fail or be misinterpreted, so it isn't valid here.